Here we have a SAT math problem. Okay, let's go to the question. For the quadratic function f of x, f of 4 equals to 8. If 0 less than or equal to x less than or equal to 3 is a solution to the inequality f of x less than or equal to 0, what is the value of f of y? Okay, now to get the value of f of y, first we need to find the quadratic function f of x. Once we get the quadratic function f of x, we can plug in this 5 for x and get the value of this f of y. Okay, we can write a quadratic function in standard form, that is ax square positive bx positive c, or vertex form, or in factor form. For my convenience, let me write the given quadratic function in factor form, that is a times x negative p times x negative q. Okay, here this a is a leading coefficient and these two are the linear factors of the quadratic function. In general, we write this x negative p and x negative q as the linear factors of the quadratic function f of x. But for the given quadratic function f of x, how do we have to get the two linear factors? For that, we have to consider this particular piece of information over here. That is 0 less than or equal to x less than or equal to 3 is a solution to the inequality f of x less than or equal to 0. Since f of x is a quadratic function, this is a quadratic inequality. Whenever I solve a quadratic inequality, I'll be getting an inequality as a solution. So here we have that inequality, the solution inequality. Okay, from this inequality, we can get the two zeros of the function, quadratic function f of x. So for that, we have to consider the boundary values in this solution, 0 and 3. So x equals to 0 is the first solution for this quadratic function f of x. That is, it's a 0 for this quadratic function f of x. The second 0 of the quadratic function is x equals to 3. That is the other boundary value in the given solution inequality. Okay, here I have the two zeros of the given quadratic function. From these two zeros, you'll be able to get the two linear factors for the quadratic function. Okay, here in the first 0, already we have 0 on the right side of the equation. So the linear factor corresponding to this 0 is just x, the stuff we have on the left side. Okay, now to get the linear factor corresponding to this 0, what we have to do is we have to make the right side 0. For that, I have to subtract 3 from both sides. Then 3 negative 3 will cancel out. I'm getting x negative 3 equals to 0. Now we get 0 on the right side. Now to get the linear factor corresponding to this one, we have to consider the stuff we have on the left side, that is x negative 3. Okay, here I got the two linear factors of the given quadratic function, that is x and x negative 3. Then we can write the given quadratic function f of x as a times the first linear factor is x, the second linear factor is x negative 3. Okay, still the given quadratic function is not complete because there is an unknown constant a. For that, we can use this particular piece of information, that is f of 4 equals to 8. That is at the place of x we have 4. So we can plug in this 4 for x over here, here and here. Then we get f of 4 equals to a times 4 times 4 negative 3. The value of f of 4 is 8. It's given over here. We can plug in 8 for this f of 4. And so here a times 4 times the value of 4 negative 3 is just 1. 8 equals to a times 4 times 1 can be written as 4a. We can divide both sides of this equation by 4. Then this 4 will cancel out. 8 divided by 4 is 2. On the right side we get a. Okay, now I got the value of the constant a. Now we can plug in the value of this a2 over here. Then the quadratic function f of x will become f of x equals to 2 times x times x negative 3. Now the given quadratic function is complete. Now we can plug in 5 for x over here to evaluate the value of f of y. Okay, now let me do it. Let me plug in 5 for x over here. Then we get 2 times 5 times 5 negative 3. Okay, here 2 times 5 is 10 times 5 negative 3 is 2. 10 times 2 is 20. Okay, here I got the value of f of y. Its value is 20. We find this 20 in answer choice D. The correct answer choice for this question is D.